Okay, we are at section 22.5, electric field lines. Um, Let me share the, um, now, electric field lines are simply imaginative construct that we use to describe the electric field. So you have to remember that this is just a mental construct, electric field lines. The magnitude of the field is greater on surface A than on surface B, because you can see that the field lines diverge. You can imagine like a flashlight of the the intensity. If you're 10 centimeters from the flashlight, the intensity is one thing, and if you go 20 centimeters, it's a little bit less. I mean, I have a LED flashlight that if you put it right in front of your eyes, it can blind you. But if it's, if my wife is holding it on the other side of the yard, it's bright, but it's not going to blind you. So it's the same with the field lines. The nearer you are to the source of the field lines, the greater the strength, the greater the magnitude of the field strength is. So that's kind of intuitive. As you get further and further away from the source, the field lines diminish because they spread out. Now that's not, well, we'll just continue on. So the electric field is the sum of all the charges that are contributing to it, divided by r squared, the distance. We're talking about the electric field at the distance r that it is from the source charges times the Ke. Okay. Now, for a positively charged point charge, for a positive point charge, the field lines are directed outward. So positive, they're going out. For a negatively charged point charge, the field lines are directed radially inward. Okay, the number of field lines leaving the positive charge equals the number terminating at the negative charge. In this case, they're both the same charge. If you would have, if the positive were twice the charge of the negative, then there would be twice as many lines coming out of it. But I'm probably jumping the gun. So the ratio of the number of lines coming out N2 over N1 is the absolute value of Q2 over Q1. So if Q2 were to have twice as many, if Q2 were twice as strong as Q1, then there would be twice as many lines coming out. Okay, now if you have two positive charges, the field lines are gonna clash, and they'll repel one another. We're gonna look at that in tonight's lab, but we're gonna do it with magnets, and you'll see similar results. Okay, let's see. Now, here's what we were talking about. Two field lines leave +2, a +2Q for every one that terminates on Q. So you can see the positive is a +2Q, the minus is just a single Q. So let's count the number of lines emanating from the positive. And I'm going to start with the line just below the blue minus dot. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I counted 16 lines coming out of the +2Q. Now let's count the lines surrounding the blue negative sphere. And I'm going to start at the same place, just below the blue. 1, 2, 3, 4, 5, 6, 7, 8. So 16 on the +2Q, 8 on the minus Q. Again, just if this is just a mental construct, but it's a way of demonstrating the field lines emanating from or going into a negative charge. Okay, rank the magnitudes of the electric field at points A, B, and C shown in the figure. Well, I would think that the A is the closest to either one of the spheres, so I would call it the first one. Now B is a little further away than A, so it's probably second. And C is right in a null spot between the two areas, so it probably has zero field because they oppose one another. So I'm saying A, B, C. And let me click over here. A, B, and C, indeed, is the correct answer. Okay, and we're going to stop there. We're going to have a pretty good discussion on the uniform electric field. Basically, we have parallel plates here with the charges on one side and electrons on the other side, positive charges on one side, and the positive charge in the middle, the little ball, is going to be directed towards the negative, away from the positive and towards the negative. But it's only a single slide. That's pretty much the end of the lecture, but we'll talk more about that, and I'll do some examples when we discuss about motion of a charged particle in a uniform electric field.